In our last video, we discussed about different kinds of chemical reactions. I told you that there are 4 different kinds of chemical reactions. Of them, the first one is chemical combination. 2 elements or an element and a compound or 2 compounds come together, they bond with each other and a new compound gets formed. This is called as chemical combination. The second one, I told you, it is chemical decomposition. A compound divides into 2 or more than 2 different chemicals. They may be elements, they may be compounds. Then you call that reaction as chemical decomposition. In that connection, we had a key experiment too. We had the voltmeter and we saw water molecules getting decomposed into hydrogen and oxygen atoms. Hydrogen and oxygen by volume, we got the collected gases in the 2 test tubes in the ratio 2:1. Alright, we will come to the third one in this class. The third, a key type of chemical reaction, a very interesting one. We call it as chemical displacement. Chemical displacement reaction. What happens here? The first example what I have given here, we had got it demonstrated in one of our classes earlier in this series. Fe stands for iron. Iron, it's an element. It reacts with copper sulfate and we get iron sulfate or ferrous sulfate plus copper. How did you go on with the experiment? In a test tube, we had taken copper sulfate solution. We had taken a few crystals of copper sulfate, got it dissolved in water, and the solution got colored blue colored solution. Now that solution is copper sulfate solution, into which we lowered 2 iron shining nails, 2 nails, iron nails. They were not rusted nails. They were bright, they were shining. We tied them to a thread and we lowered into the test tube. We left the iron nails for about 2 to 3 minutes in the copper sulfate solution. Then we took out. As we took out, surprise awaited us. What was the surprise? Nails were no more shining in their metallic luster. Color had got changed. They had become brownish. They were looking like copper nails. Very interesting. Iron nails had got their coating changed now. What was the reaction then? Here in this reaction, one is copper sulfate, which had copper in it. The other one is iron. Iron is independent, an independent pure element. Iron is stronger than copper. Iron is stronger than copper. Iron displaced copper from copper sulfate. It pushed it out. And iron occupied that place. So it became iron sulfate, and copper that got displaced here, we see it separate here. And the iron nails had got a coating of copper. This displaced copper had got accumulated all around the iron nails. And we see the iron nails brownish in color They looked as if they were copper nails. Iron nails were looking like copper nails because they got a coating of copper. Now here, the key aspect is that iron replaces copper from the copper sulfate solution. Iron displaces copper from the copper sulfate solution. That's why we call the reaction as displacement reaction. Very easy to write. Remove Cu here, as we discussed now. Put Fe there. It becomes FeSO4. And Cu, you write it separately. Iron plus copper sulfate gives iron sulfate plus copper. Let us take another example. Zinc. Just as we found iron, zinc is also more powerful. It is stronger than copper. Zinc plus copper sulfate solution, same thing. Zinc is stronger, it dominates, it pushes out copper from copper sulfate, and zinc takes the place of copper, and we have zinc sulfate here plus copper. A similar reaction, instead of iron, we have used zinc here. Accordingly, the reaction varies. We will come to the third. Lead. Pb, plumbum. Plumbum stands for lead. Pb is lead. Lead. Usually, we say lead is broken. When the pencils, that tip is broken, we say lead is broken. Actually, it's not lead. It is graphite. It's a misnomer. Everyone says that. Oh, my lead is broken, my lead is broken. And you sharpen the pencil again. But remember, it is not lead, it is graphite. Lead is strong. It has a higher strength. And lead here in this reaction, it displaces copper from lead chloride. Say it has become lead chloride now. From copper chloride, lead has displaced copper, and we have got lead chloride. The displaced copper here, we see it separately in the equation as Cu, copper. Cu stands for copper. So lead plus copper chloride gives lead chloride plus copper. A similar reaction again. So from these three reactions, we see iron, zinc and lead. Three elements. Three metals. All the three are metals. They are more reactive than copper. That's why they are capable of getting copper displaced from where it is and occupying the place of copper. All these reactions, three reactions, you compare and study together, because you see a common concept that runs through all these three reactions. So, iron, zinc and lead are more reactive than copper. Lots of chemical reactions you come across where displacement is the key aspect. Let us move to the fourth one now. Fourth kind of reaction. We learnt about displacement. Now we move one step further. Double displacement. It is not one displacement that takes place, two displacements. Here to one displacement. Among the reactants, there is one displacement here, one more displacement this way. Both ways it goes. Beautiful. Here, Na2SO4, sodium sulfate. Make a solution of sodium sulfate in a test tube. Take a few crystals of sodium sulfate, put it in water and stir it well. You can stir it or give wild shakes. Sodium sulfate will dissolve in water. We have sodium sulfate in aqueous condition. What is the aqueous condition? It is dissolved in water. It is dissolved in water. Plus, in another test tube, you take some water, half the test tube of water. put a little bit of barium chloride, BaCl2. Ba stands for barium, Cl2 stands for chlorine. Get a solution of barium chloride. You have two solutions now, sodium sulfate and barium chloride. Now pour barium chloride solution drop by drop into sodium sulfate solution. Reaction takes place. Very interesting again. Here it is not one displacement that takes place, a double displacement compared to the third one. Where is it? Sodium displaces barium here. Barium won't keep quiet. Barium displaces sodium here. Both of them replace the positions where the two were looking very stable, prominent, they were displaced. So sodium gets together with chlorine and it becomes sodium chloride. Aqueous, it's dissolved in water. Then barium joins with SO4 sulfate and it becomes barium sulfate. Easy to write here while equating, only thing Na2SO4 it is. But when it becomes NaCl, because of the ions here that get exchanged, it will be NaCl. So you can't write it as Na2Cl. You have to write it as NaCl. But you have two atoms of Na, so make it 2Na. Cl2 is here. Now it becomes 2Cl. So 2NaCl, aqueous. BSO4. How do we know the reaction has taken place? When you have mixed the two solutions, you find certain substance floating in the test tube. It is white color. We call it as precipitate. What is precipitate? When something doesn't dissolve, stands separate, starts floating in the other substance, other liquid, you call it a precipitate. In short, you can even write it as PPT. PPT or precipitate. Precipitate. This word is again used in chemistry. The white precipitate you see when the two solutions react, it indicates that barium sulfate has got formed. They are the crystals of barium sulfate. They don't dissolve in water. They don't dissolve. That's why they will be floating. So you find a white precipitate of BaSO4 or barium sulfate. I think you are clear about the reaction. Two chemicals coming together and both of these exchange their radicals and they become new compounds, and the equation what you get or the reaction what you get is a double displacement reaction. See, here is a displacement reaction. Here you have added one more prefix, double. Two displacements. Double displacement. Let us have another example here. PbNO3 within brackets twice. This radical, two such radicals get along with one atom of Pb. Pb you know already, it is lead. So you call this as lead nitrate. Lead nitrate, the formula is a bit complex. PbNO3 twice. That means in this molecule of lead nitrate, you have one atom of Pb. See, two atoms of nitrogen. These two encompasses both these nitrogen, and O 3 into 2 6. 6 atoms of oxygen. Together it becomes lead nitrate. Now here you add potassium iodide. K stands for potassium, I stands for iodide. Ki. Again it's a double displacement reaction. These two they get shifted to each other's place and it becomes lead iodide, PbI2. It's a yellow precipitate. It doesn't dissolve in water. Plus KNO3, potassium nitrate. See, potassium has taken charge of nitrate. Lead has taken charge of iodine. So there's a double displacement and this is what you get. This yellow precipitate, what you find in the test tube when you do the chemical reaction in the lab, is indicative of the formation of yellow precipitate of lead iodide. As you study chemistry, you come across lots of double displacement reactions. So know well, there are 4 different types of chemical reactions. We will be studying one more of this sort, but these 4 form one class, one group. So in our next video, we will move ahead and study about the other chemical reactions. Thank you.